Yeah, we can start.
So, a warm welcome, sir. Very good morning on behalf of FTP and behalf of IAPM. I myself
Thank you so
am
much.
Venugopal, coordinator of this and coordinator of Mr. Dr. Ganesh Kumar also. And I would like request, dear FTP team, can you please introduce our resource person?
Greetings of the day. It's a great pleasure for me to introduce our speaker, Mr. Lohithaksha Maniraj Maiyar, Assistant Professor at IIT Hyderabad in the Departments of Entrepreneurship and Management. He had his PhD from IIT Kharagpur, Optimization in Logistics, Materials and Supply Chain Management. I feel delighted to invite Mr. Lohithaksha Maniraj Maiyar to share his insight. Over to you, sir.
Sir, before just hand over to you, so this is a 5 days FTP program, virtual, sponsored or funded by the Atal Academy, AICT in New Delhi. Successfully, we finished 4 days, and this is last day. I would like hand over the session to you, sir. Now, sessions to you.
Okay. Thank you so much for the warm welcome and opportunity to present the experiences from our previous project. So I am Dr. Lohithaksha Maniraj Maiyar. Currently I am assistant professor in the Department of Entrepreneurship Management, IIT Hyderabad. I recently joined here last month, and before joining here, I was actually involved with the REAMIT project, about which I will be talking today. And I was like 1.5 years almost. I worked as a postdoc researcher in this project. So this is an extension of my PhD. My PhD was on, as introduced by Madam, my PhD was on modeling and analysis of efficient transportation for food grain supply chains, which is basically non-perishable item. So my focus was to develop transportation network design for the Indian food grain supply chain system. And then this project interested me, and applied for this uh, because of its relevance with my PhD, which is now this focuses on perishable food items and uses big data and IoT to reduce food waste. So that was my motivation to work for this, and I had a good experience, which I would like to share with you all today. So the topic of today's presentation um, is big data and IoT in agri-food supply chain management. So I would be discussing first, before jumping into the project, first brief introduction of what is this big data, and you may already know, but just to revise this concept, and then move forward for what is REAMIT project and some cases that that REAMIT project is currently aiming to solve and reduce food waste in different regions across the United Kingdom and Europe. Previously, it was one single Europe, but then because of Brexit, now it's divided into UK and Europe. So, but still, the project addresses both all the regions across UK and Europe. So, yeah, first outlining about the presentation today. Like I mentioned earlier, we're discussing briefly about big data and Internet of Things. What is the relevance and use of big data and IoT to agri-food sector? How big data and IoT? Yes.
Full screen make it, sir.
Is it not full screen now?
Yes, no, sir.
PPT, not full screen.
I think I have just made it. I mean, I'm working from full screen only.
Okay.
Let me just stop share, and I'll try another way. I'll try to share the whole screen instead of the window.
Yes.
That might be helpful. So I'm.
Yes.
Now fine, sir.
Now is it fine? Okay. So yeah, I hope yeah, this is the first slide. So just briefly discussing the outline. Some introduction on big data, Internet of Things, how big data would be used in agri-food sector, how big data analytics can help bring sustainability into the agri-food supply chains, and then finally the REAMIT project and cases from REAMIT project. So basically, big data is now the norm, is most kind of a buzzword in business analytics. So it generates, because of generation of a huge volume of data in the presence of huge amount of technology available with us, kind of different types of sensors available with us to bring data. So we get lots of data in the form of structured as well as unstructured formats. Um, and when we have big data, usually means any data set that is too big to be efficiently worked in real time with traditional database tools. Um, so it is basically driven by 4 V's. If you already know, it's volume, veracity, velocity, and variety. We'll just briefly see what the definitions of these. Um, so different sources of big data are mobile phones. We have several devices, IoT devices, which are responsible for generating huge data. Businesses have also realized that these data could hold promise to give deeper insights into their customers, partners, and businesses. So because of these large amount of data being generated, there is a fifth V also nowadays coming into picture. That fifth V is value. That is, despite volume, veracity, velocity, and variety that define the big data, after it is collected and based on the kind of quality of data and the kind of use that is to the stakeholders, to the industry, to the different agencies, the chunk of data that you own um, also has a value. So there are 5 V's instead of 4 V's as a fifth dimension of big data. So a brief discussion on what is veracity, volume, variety, and velocity. So veracity is the quality of the big data that we have, and reliability, basically how reliable the data you collect is, and how you can, because basically if you want to do data analytics, it is there's a saying that garbage in, garbage out. So it is important to uh, have the quality and reliable data while you do data analytics, any kind of either normal or big data analytics. And of course, volume, the growth of data from terabytes to yottabytes. This gives rise to the need for additional data dimensionality reduction techniques to learn about how to reduce the huge dimensions available in the big data to workable number of dimensions. And then variety. So because of the type of data, which is not only structured, but you can also see unstructured data and semi-structured data in the kind of data that you receive, you need to pre-process such huge amount of data. And finally, velocity is if you want to do real-time computations with the help of big data. The main aim of capitalizing on big data is to uh, use the large amount of data to do some real-time computations. So in order to be able to do that, we have the speed of data with which the data comes in and gets stored into the server is very high. So the technology should be capable of dealing with such high speed of data. Um, and synchronization of time is very important. So let's see how, I mean, just a brief introduction on the evolution of Internet of Things, because the REAMIT project is basically uses IoT technology. So IoT technology, how did it come? I mean, what was the evolution? So as you can see, the industrial revolution was started with the mechanization and using the basic uh, water power and steam power in 1784. So as you can see, this is a picture of the first power loom, which was used during the industrial revolution, the first industrial revolution. And then it came, and then the next revolution was when assembly lines were introduced and mass production was being done by Ford manufacturing in the western regions of the globe. So that's when again slowly it moved on towards in 1969, when the computer and automation came into picture. It was the next kind of industrial revolution, which totally replaced the mechanical systems into computerized systems, programmable logic controllers, mechatronics. All this came into picture. And then in the recent past, cyber physical systems. All of these were developed in the context of manufacturing, production, and finally, cyber physical system also is an inclusive kind of system which uses Internet of Things for manufacturing domains. And this kind of advantages that were reaped because of using IoT systems were spread across different domains. Now, lots and lots of domains are using not only in manufacturing and production, but also in several other service sector. IoT is being used, and this is considered as a revolution like we are currently using in uh, supply chains. Uh, uh, Not only food supply chains, many other kind of supply chains we use. There is a huge amount of use of IoT technology to extract data, and that's why big data is coming into picture. So this is the history behind the evolution of IoT and cyber physical systems, etc., which is also called as Industry 4.0. Um, so now Internet of Things, why has it come, or why has it become more important? Because of the existence of several wireless communication devices and the evolution of the internet, 3G, 4G, 5G. So there's technologically evolving internet protocols. Also, then that's on the software front, and on the hardware front, we have several types of hardware that are coming up, such as radio frequency identification tags, sensors, actuators, smartphones, etc., all supporting us to generate lots and lots of data. And there is these sensors which can interact with each other as well, to some extent, and generate this data. So this is why Internet of Things is more prominently used in these days. And there are different domains in which, as I mentioned earlier, transportation and logistics, healthcare, smart environments, personal and social uh, so, domains also. And there are several futuristic applications which IoT promises to develop. So this the different domains. And in the UK context, we can see that IoT and big data are being used by several companies, such as Transport for London is a company which uses IoT and data. Vocalink, which is a transaction service to banks, and there's a retailer called New Look. New Look had it uses used big data uh, to to design the products for the new types of clothes, new fashion trends, etc., based on big data and based on data from customers who have purchased previously and their opinions and their online reviews. So New Look, but nowadays New Look is no longer being operated. And BT is a telecommunication device which also uses big data for as an application. And supermarkets and online chains such as Asda, Coop, and there are several supermarket online chains which are using big data, and also uses and many SMEs also use big data. So what big data and IoT has can promise in Agri-Food domain. So if you have tractors with sensors, would help us to track the soil and crop conditions for use by farmers. And we have online mapping of weeds, weather data, social media data to predict marketing trends and consumer sentiment for specific foods. Um, then there are several success stories which one can always refer to in these references, predicting how weather data with big data, and they can provide targeted insurance to farmers based on the different types of weather conditions for a particular region. So there are several types of predictive analytics that we can do with the help of data available. As far as the sustainability implications are concerned, the Food and Agriculture Organization says that there is 1.3 billion tons of food which is wasted in the world every year. So 40% of food in America is wasted, and 20% of food that we buy never gets eaten. That is all wasted. So according to the statistics shown by www.savethefood.org,
So it was struck. Video not coming. So, Lohithaksha sir. Hello, Lohithaksha sir. Sir.
I think he got disconnected.
Yes, yes. Some technical issue. Dear participant, we'll wait for 2 minutes. I think technical issue.
I'm calling, sir. I'm calling the.
Yes, yes.
Yeah, you join again. Huh? Yeah, some internet issues. You join. So, Venugopal sir.
Yes, sir.
You engage, sir. You talk about this examination, all these things.
Yes, it is. Dear participants, a small announcement for afternoon session due to some emergency, due to some other reasons. That is, Mr. Arvind from Crop in Bengaluru will not engaging. And instead of that, many people requested Ganesh are going to be handling a session for half an hour, going to be talk about different sorts of open availability of data. He will show entire how open availability data is available. It will be in half an hour session. After that, followed by your MCQ question answer examination part. Examination which contain 40 questions for MCQs and 9 marks for open-ended questions. Open-ended questions exclusively for your descriptive type. Like you can write about the session wise, what is your outcome, what is your enhancing skills after the sessions. That will be continued, and after that we'll have a validity and feedback. So this is the schedule for afternoon. The exam will be start by 2:30, will end by 3:30, and half an hour will have validity and whatever validity function, all these things. Okay. And
apart from MCQ, there will be open question will be the sir.
yeah,
Key takeaways.
told sir.
Key takeaways also will be there. There is no right or wrong answer. Just you want to give what is the key takeaways.
Yes, sir. Yes, sir. That is what.
In assessment based on MCQ only. If any
Yes.
marks anything, we'll consider these also.
Because all MCQs, whatever you got it score, we'll just upload to the AICT. Now straight away AICT will provide you.
Excuse me.
Yes, please.
Sorry to interrupt. What about the session for the AI in agriculture?
That is what I told you, right? Due to some other reason that the resource person is not available. So that's the reason Ganesh sir will engaging for half an hour session. That's exclusive talk about different source of data.
Okay. Sir.
Open availability data. Okay. That is for half an hour. It will start by 2 o'clock, will end 2:30, followed by 2:30 to 3:30 examination, which contains MCQ questions and as well as open-ended questions. The only MCQ questions we will consider for your assessment. After that, validity like 15 minutes. That is a afternoon schedule. Accordingly, we can go. Clear, sir? Aditya, Maiyar sir. Is it clear? Hello. I think that is all no afternoon schedule. Ganesh sir, I'm audible, right? Ganesh sir?
You're audible.
Yes,
You're
sir.
audible.
Thank you. Thank you. I think Sar is there.
Hello.
Yes, sir. So welcome, sir. Voice is somewhat disturbing. Just we'll wait for 2 minutes. Sir will join. So we'll wait for 2 minutes, sir. Sir will be joined. I think some technical issue happened.
Hello, sir.
We can hear you, sir.
Yeah. Sorry for the inconvenience, sir. Because of internet
No issue, sir. No
instability.
issue. I understand, sir. No issue, sir.
Yeah, I'm just going back to my presentation.
Yes, yes, please. Sir. I made co-host. Okay. Thank you.
Okay. So, did you lose? Did I lose the connection? Do you remember which slide?
Previous slide, sir. I think 30% is something in that, sir. That.
Previous.
No, before that, sir.
This one.
No, before that slide. No, before go.
Go, sir.
30% food waste, something.
This was sustainability implications. You said sustainability implications of it.
Okay.
No.
Okay.
No, sir.
I think this.
This not this one, sir. I think this slide, no, sir. Lot of waste in that American food waste. That.
40%.
Yeah, this is the one which I was. Yeah, 40% of food in America was wasted, and 20% food that we buy never gets eaten.
Yes.
So I'll start from here.
Yeah. Full screen.
Full screen.
Yes. Yeah. I made the full screen now. Are you able to see?
No, sir.
No, sir. Yes. Now.
Yes. No. Gone. Again gone.
Okay.
Yeah. Fine.
Yeah. So yeah, I was taking some presenting some statistics from www.savethefood.com. It says different types of percentages of food that never reaches the table. Seafood 50%, fruits and vegetables 48%, grain products 38%, meat 22%, milk 20%. So these are some statistics which say motivate us to focus on reducing and I was presenting that how climate change is also a reality, and it's impacting also, I mean, contribution of food waste or carbon footprint from food waste towards climate change. So to understand that, what is climate change? Climate change is basically the change in climate due to several operations that we do basically on the planet, and which results in the carbon and GHG emissions, which finally end up giving rise to some events such as global temperature rise, warming of oceans, shrinking ice sheets, glacial threats, decreased snow cover, sea level rise. And these are some statistics that help us to understand how food waste is contributing to climate change. So first we need to understand how much is food wasted. So this is some statistics from one of the presentations made by Alexandra Heaney, who's a PhD candidate in Stanford. He presented that the total amount of food waste in landfills for US is equivalent to 2% of energy consumption and 25% of US methane emissions, which is the food waste from landfills is giving rise to this much of energy and emissions. So it's important to focus on carbon footprint from food waste also. And these are some statistics from Food and Agricultural Organization (FAO), which says which shows the food wastage and the contributions from each food wastage towards carbon footprint. So this is the link we can have from food wastage, how they impact the climate. And finally, these are some videos that you can see and refer to, which highlight the importance of sustainability implications of from the food waste. So how can big data and IoT help in reducing food waste? There are several sources of data that we can take from the food supply chains. So food waste saved is much more than the value of waste. That's the tagline. When we focus on reducing wastage, we may not get or the business may not gain much monetary value, but the food waste saving itself is important because of sustainability and several other social and environmental benefits. And smart sensors can keep track of freshness of the food, including temperature, color, and odor, which basically avoid food wastage and help us not even to generate the food waste in the first place. So the smart sensors can be used in the first place, and then RFID tags can contain full information on the date of harvest, date of processing, date of transport from factories, continuous monitoring of temperature, odor, color, and different types of parameters that define the quality of food basically. So this is how sensors can help us to monitor, track food waste and control food waste in the food supply chains. And for some supermarkets, sensors can support decisions on whether to sell at a discounted price, donate to charity, or send to landfill. So these decisions are critical to the businesses in terms of how much they can save once they realize that food is being wasted. So there are different decisions that we can take at different stages of the food waste supply chains. And sensors in smart fridges, we can install sensors inside the smart fridges, and they can be connected to smartphone apps. Which can ultimately make aware the different actors of the supply chain, right from the farmers, transporters, distributors, and retailers. They can be made aware of what's the status of the food product being stored in the fridges, if they are being overloaded, or if there is more capacity available to store in the fridges, or if there is a power shut outage, and you can know remotely whether the foods are being wasted, or if the temperature thresholds are going lower than what they should be in the cold storages, etc. So these cold storages can be made smart, and manual intervention can be made as minimum as possible. um, and usage of smart garbage bins, smart waste management systems, and smart garbage trucks. So all of these are made possible with the help of IoT sensors available in the market. There are huge amount of commercially available IoT sensors which need to be taken for the particular application. So, and finally, there are some apps in the UK context such as Olio, which help us to say, for example, if in a household, if you know that we have ordered some food and some of the food is not used by us and it's getting extra, you can always mention in this Olio app that we have so much amount of food. And these are food sharing apps, and people can either collect from you, or you can go and deposit into donation bins or food collection outlets. So finally, the kind of technology architecture that we use, a generic technology architecture that is generally used for the implementation of IoT is three-tier architecture. So the first tier is known as the edge tier, which essentially collects the data from different sensors. The sensors send the data from primary locations such as inside the trucks, or from inside the farmlands, or from inside the storage locations, processing centers, or from any intermediate hubs, facilities, etc. The sensors are installed in the primary data collection locations, and then they are transported into gateway. So from the gateway, they are then transported into the storage hubs, or central storage, or intermediate temporary storage, or central storage. So this is the functions that generally are carried out in the edge tier. So different types of sensors and gateways will be chosen based on the type of environments, whether it is stationary, or whether it is moving, or whether it is on trucks, or vibratory environments, etc. So the different kinds of sensors are available for different kinds of applications. So this is the total work being done in the edge tier. And then once the data is received, then the total data processing is conducted in the platform tier. So data processing and decision making, etc., is made in the platform tier, where the software platform basically collects all the data, pre-processes all the data, and conducts the data transformation required for doing the data analysis. So data analysis can be either done offline or online. Online means for real-time data. Offline means for historical data. So this can be done, and relevant insights can be developed, and again the results can be again stored in another database, which needs further protection. So this is where as I mentioned, the fifth week comes into picture. So once we do all this, then this kind of data might be used for certain stakeholders, where it has a value, since some amount of processing is done on the data, and we have done some value addition to the data. So in this way, it is important to store and protect the data, and to comply with the data trust, because many industries, they would want the data to not be shared with everyone. So this kind of data confidentiality, data trust, data privacy all comes in this stage. when we want to store the data for longer period of time, it's important to have defined metrics to store the data and to use the data compliant with industry policies and data. For example, GDPR is considered very important in the UK, which is known as data protection policy, GDPR policy, which is important for saving the data, for personal data and industrial data for all the stakeholders involved in the project. So such policies need to be compliant with, and for that purpose we need a separate tier which is known as enterprise tier, which generally integrates all the departments, all the functions. Here the data is now being shared across different functions of the organization or two or more organizations. So in this case, all the data trust, data privacy issues come into picture, and it's important to maintain the
Yeah, I think it's disconnected. 1 minute, I'll just call the resource person. No, he's not muted. I think some minute I'll call him.
Seems major technical fallback.
Hello, sir. Is my voice audible now?
Now it's audible, sir. You can share your screen, sir.
Yeah.
Yeah, make it full screen, sir. Yeah.
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 So,
yeah.
okay. Yeah. Thank you. So I was telling about the food wastages across the different stages. So there is huge amount of scope to reduce the food waste even before it reaches the household. So this is categorized into a food waste pyramid, which is 5% of wastage for wholesale logistics, 11% for primary production, 12% for food service, 19% for processing. So the first four levels of the pyramid, the top four levels of the pyramid can be focused on, and that is what motivated for the proposal to write the REAMIT project proposal. And it focuses on the pre-household food waste. with the use of big data and IoT to reduce the pre-household food waste. So that's the motivation for REAMIT project, and REAMIT actually stands for improving the resource efficiency of agribusiness supply chains by minimizing waste using IoT sensors. So this project is a consortium of several academic institutions, industry partners, where academic institutions, University of Bedfordshire is the lead partner, and we have other institutions such as University College Dublin, University of Nantes, Nottingham Business School, IT Trally, Ulster University, and yeah, these are the different academic institutions. And as far as the industries are concerned, Images and Riso from France, Levstone again from the UK, Visor, Cenex, Valorial Action Sense. So these are different industries. The main functions of different organizations I was presenting earlier. And Professor Ramanathan from University of Bedfordshire is the lead investigator of this project. I was a researcher postdoc under Professor Ram for the time period I was associated with the REAMIT project. So the challenge that REAMIT aims to address is the amount of food waste. As you can see from the Northwest Europe region, is 35% of food waste in the EU 28 has occurred in agri supply chains. So once EU 28 is the 28 countries of Europe. Now, since UK is out of it, it's known as EU 27. So this is the amount of food waste in the Northwest region alone. So we aim to reduce this at least by 10% by the end of the project. REAMIT focuses on fresh foods. Now, fruits, vegetables, fish, and meat. These are the 4 categories of food that REAMIT originally intended to focus on. But now, based on the interest of different industries, we are open to apply the REAMIT technology for other food categories as well. We're slowly trying to they are slowly trying to extend to liquid foods such as milks, juices, and other liquid foods. Then REAMIT challenge, basically it aims to address the challenge by demonstrating the power of IoT sensors and big data, as I mentioned earlier, in improving the resource efficiency of agri-food supply chains. So the REAMIT project aims to deploy IoT sensors for reducing food waste and hence improve resource efficiency. They aim to collect the data in the cloud and conduct big data analytics to identify sources and patterns of food waste with due to tackling them. So this is what REAMIT project aims by the end of the project. It wants to reduce the food waste across the NWE region, which is Northwest Europe region, by at least 10%. And the corresponding emissions from this 10%, which will amount to around 5.5 metric tons of CO2 per year. That also we aim to, REAMIT project aims to reduce. So to reduce food waste and to also subsequently increase the productivity of the supply chains due to amount of resources such as water resources, nutrient resources, fertilizers, etc. Food waste saved is much more than the value of food waste. So as I mentioned earlier, there was a tagline that food waste saved is much more than the value of food waste, because we ultimately end up saving so many amount of resources which will be beneficial to the society, so the environment and the social causes. So the technology that we aim to use is the same thing, which is explained figuratively here. So the REAMIT project aims to install several kinds of sensors inside the trucks. Ultimately, it will transmit all the data to the big data hub server and provide alert to the mobile apps. So all the actors on the supply chain would be having these apps installed in their mobiles, such as the farmers, the production warehouse managers, the truck drivers, and the retail store managers. And so all these will have this app, and the app will have real-time data about the quality of food and where the food is transported in real time. So this is the timeline of the REAMIT project. The total budget of the project was about 4.8 million euros. Start date was 10 January 2019, and it's extended until actually 2023. Previously, it was only till 2022, but because of COVID, the several companies have not participated in the project, and because businesses is the main priority for them, and because of which the funder organization was happy to extend the project for another 1 year, so it's extended till 2023. So it's co-funded by Interreg Northwest Europe program. Co-funded means 60% of the fund is from the organizations participating in the project, whereas 60% is from the funding organization, whereas the remaining 40% of the fund is from the organization itself. So from the participating organizations. So implemented by 12 partners from UK, Ireland, France, and Netherlands. And there are other 6 associated partners as well. So totally there are 6 universities, 3 SMEs, 1 food production enterprise, and 2 business development agencies. University of Bedfordshire as a lead partner. So these are the different partners. Mainly the sensor installation, we have like 4 to 5 piloters running at the moment. Piloters means the companies which are happy to provide a platform for testing and demonstrating the REAMIT technology. So Visor is a partner organization which is shown here. Visor is a partner organization which installs the sensors into different pilot organizations, and there are several partners who do the data analytics after the sensors are installed and data are received. So Levstone, Senex, University of Bedfordshire are responsible for doing the data analytics, and there are some academic institutions who are helping us to develop advanced sensor technology such as Raman spectroscopy and 3D fluorescence. So in addition to the traditional sensors available such as the temperature, CO2, and etc., which I will be explaining in the further slides, some organizations are doing research for advanced sensor technologies and to collect data using these advanced sensor technologies. So that's the role of other organizations which are shown here. And before we move on to the exact pilot scenarios, let's have a brief introduction on what roles as a lead partner University of Bedfordshire aims to provide for REAMIT. So the ship is to provide a subsidy contract with the funder. It designs REAMIT partnership agreement and ensures project implementation in line with partnership agreement and approved application, ensures strategic objectives set for the project are met, and then all the finances, reporting, and all these activities, generating reports to the funder. And finally, as far as the data analytics is concerned, we, University of Bedfordshire, aims to store all the data received from the pilot test, and we have built a server, big data server, which essentially gets all the data from all the pilot tests and sends it to all the partners, and it also serves as a platform for doing the data analytics in addition to all the day-to-day routine coordinating activities. So the REAMIT approach basically replaces the traditional food supply chains with the IoT technology. So this is the traditional food supply chain. Fresh food in the supply chain is either traveling to the intended customer either through food in process or through on the move. So we aim to deploy the sensors in the production sites, in the processing sites, or the transportation vehicles. And then all the data from these 3 sources basically are transported into the storage platforms and linked with the data analytics module, which will generate the respective alerts and sent to the smartphone app, and which is ultimately communicated to the different actors of the supply chain. So if the food is not of the appropriate quality, if it is found that food is not of the appropriate quality, then it is transported to the nearest customer instead of transporting it to the intended customer. So if it is transported to the intended customer, then if there is a potential, if the app says that there's a potential of reducing the wastage, if there's a potential of quality degradation, and by the end it reaches the intended customer, the quality itself is not appropriate, then there is no use. So it will be transported to the nearest customer. Nearest customer can be the either food banks or nearest supermarket across the transportation network. So these are identified by the AI techniques, and finally communicated to the app so that the truck driver can take the respective action. So in the REAMIT project, we aim to use, like I mentioned earlier, both traditional kind of sensors to collect data and also newer sensors. So traditional sensors are temperature, humidity, carbon dioxide, atmospheric pressure, light sensors, volatile organic compound measurement sensors. So these are already being used now, and under research, there are new sensors which are being conducted by, for example, Raman spectroscopy is conducted by University of Nal, where they are trying to predict the quality of samples of food using Raman spectrometer. So about which I will be discussing in the future slides when I present the scenario and case study of this particular Raman spectrometer case study. And the kind of techniques that we use are big data analytics, artificial intelligence, decision support tools. So with the help of artificial intelligence and decision support tools, the REAMIT project aims to um, identify the nearest consumption points, such as local store food banks and food charities. And with the help of decision support systems, the REAMIT project aims to develop or optimize the food delivery points based on real-time food quality monitoring. And it also aims to monitor the quality of food, thereby monitor the quality of food and devise efficient strategies even right at the source, so that the quality of food is maintained for a longer period across the supply chain, so that thereby increasing the food shelf life with the help of real-time cold chain monitoring. And food owners, truck drivers, and warehouse managers will be connected using a dedicated smartphone app, as I mentioned earlier. So this was the progress earlier in the REAMIT project. So as there are huge number of sensors available in the market, so it's important for each pilot test to do a thorough analysis of what kind of sensors is applicable and can be used in the appropriate budget and in the so that these sensors can address all the problems that the companies have, like reducing the food wastage or monitoring the quality of that particular type of food. Whether different types of environments are there, means there can be dry environments, there can be chilled environments, there can be frozen, there can be wet humid environments. So for different kinds of environment, there's different types of sensors available. So this review is being conducted as and when the pilots are approaching. So for each pilot, this is an ongoing process until the end of the project, the sensor review. And a framework for measuring waste and avoid carbon emissions is being developed, so that each of these waste reduced can be linked to the amount of carbon emissions reduced. A big data server, as I mentioned earlier, has been procured and installed and given access to different partners, so that they can send the data, receive the data for collecting the data from sensors, and also as well as analyzing the data by the data analytics partners. So 5 pilot tests, as I mentioned, are currently being executed across different Northwest Europe countries, UK, France, Germany, and Netherlands. And now data collection has already begun from 3 pilot studies, whereas 2 other pilot studies, because of COVID, they have agreed to participate, but it's getting delayed because their priority is mostly to address business needs, and they don't have time for research projects. So although they are happy to participate, but it takes more time because of the COVID disruption. But 3 pilot tests are running smoothly, and besides COVID, they are very helpful to provide this facility, and we are receiving the data now onto the big data server from these pilot tests. So moving on to the pilot scenarios. Um, so the pilot test in Netherlands, for example, deals with the transportation of fresh food from a fulfillment center to the final customer. So this company aims to replace the traditional supermarket or kind of supply chain where customers go to the supermarket and buy instead of that, there are many online companies already present, but they are trying to deliver in the Netherlands using online order system, just like we have Big Basket in Indian context. Similarly, they are trying to replace in the Netherlands, and they have a very good customer base. It's a small and medium scale industry which are now popular in this region. So they are facing some problems, and while they transport the food, they are facing challenges with respect to maintaining the quality of food. So they want to use REAMIT technology to overcome these challenges. So what are these challenges? Let's have a look in the further slides. So this is the picture you can see is the kind of e-truck that they use. They have different crates in this truck, which carry a combination of orders from different customers. So they accumulate all the orders in the fulfillment center and use this e-truck, accumulate, consolidate all the orders in this fulfillment center and send it to customers finally. So in the meantime, during the transportation, they have a 1.5 hour or 2 hours time of traveling, in which they have to maintain the quality of food in the appropriate level. So right now, what they are using is to maintain the quality. This is the same configuration of the online food supermarket. Right now, what they are using is cooling packs. Cooling packs uh, is just like ice blocks, cooling packs, ice blocks. They deposit different cooling packs across the crates, across the different portion of these trucks, and they follow thumb rule kind of based on their own experience. They follow this thumb rule kind of approach to maintain the temperature, which is not very accurate. So they want to replace this thumb rule kind of approach and have a scientific way of monitoring the temperature or maintaining the temperature. So if the season changes, for example, from summer to winter, then their thumb rule kind of technology, they have to remember lots of things in order to maintain the temperature. Say for summer, different amount of ice packs in different portion of the trucks, and for winter, different amount of ice packs in different portion of the trucks. So if the employee changes, then again the experience will be lost. So they have to do it all over again. So because of these challenges, they want to use technology and deploy sensors in each of these crates, maybe one sensor per each crate, or one sensor for 3 or 4 crates, depending upon the temperature variation. They want to install this and monitor it online and remotely from their offices. So they can have a customized temperature profile for each customer based on the type of the product. For each crate, based on the type of the crate, if it is ambient or if it is chilled or if it is frozen. So for different crates, there can be different temperature profiles, which are basically known as customized temperature profiles for maintaining the quality of food. So this is one application which REAMIT project aims to address in the Netherlands. And there's huge amount of data that can be collected, because for every 5 seconds you can tune the sensors to receive data for every 5 seconds or for every 1 second or 5 minutes, or depending upon the capacity of the storage of the server. You can tune the sensor. So the sensors itself come with different frequencies, different resolutions in the market. So if lower the resolution, higher the resolution, higher is the price of the sensor. So you have to really optimize the cost of the sensors and cost of the technology in order to give optimized results to the customer. So this is the architecture or the flow diagram of data. So as you can see, all the sensors would be installed on the truck, as you can see here. So there will be a GPS sensor, there will be different kinds of sensors, temperature sensors, and that will all be sent to the gateway, which will be either installed on the back of the truck or near the driver's cabin or on the top of the driver's cabin. There are several challenges to the practical implementation of this also. It's because when we try to install the gateways in the truck, several of the drivers have had issues saying that we don't want to be exposed to IoT devices because it is a concern of health. These radiations may be a concern of health to the drivers. So they are not very friendly to accept the installation of gateway on the trucks. So these are some challenges, practical challenges while the implementation of this project. But as an alternative, the installation company has suggested an alternative way to do this. That is by installing the gateway somewhere on backside of the trucks or an alternative location, which is user friendly or not very harmful to the drivers or the trucks. And there can be alternative sensors that can be thought of, which do not actually require a gateway, or which has an inbuilt sensor transfer, data transfer inside the sensors itself. But in that case, the per sensor cost would be higher. So these are some challenges, but if the primary goal is to not harm any of the drivers or to adhere by the health constraints of the drivers. So even though it's higher cost, it's important to abide by the health restrictions, etc. And then once we get all the data from these food items, they're transported to a temporary cloud known as REAMIT Visor. So the Visor company, the installation company, hosts a cloud, a temporary cloud, and from this temporary cloud, the pre-processed data is sent to the central storage at University of Bedfordshire. This is a second storage. The data over here is permanent, and the University of Bedfordshire backs up the data for every weekly for now. And once the data starts to come in continuously on a daily basis, then there will be daily backup of this data, which is stored at the central server at the University of Bedfordshire. So from this server, all the data is then sent to data analytics partners to do the required data analysis. So as I mentioned, one of the problems they want to address is to develop customer temperature profiles for each food crate. The second problem that this pilot aims to solve is to map the customer complaints with the acceleration profiles of the food items. That is, some of the customers have complained that food is damaged, food is not arrived in the right quantity. Maybe an apple is crushed, or maybe an apple is half semi-crushed, or just a scratch. So for different levels of damage, the data that is received will be mapped with the acceleration profiles of the truck. That means uh, so for which particular the acceleration profiles will be linked with the time. So it is a time series data. Time series data means for which time what is the profile of the acceleration of the truck. So if there is a major variation in the acceleration of the truck, then that particular variation will be linked to the customer complaints and will be seen if the damage is caused during the transportation phase or not. So these are some efforts that are being carried out to address the practical problems of this pilot test. So this is the same kind of architecture that I mentioned earlier. So sensors, data from sensors and weather data, GPS data will all be sent to the sensors, to the temporary cloud, taken from the cloud, and will be sent to a central storage server, which is at University of Bedfordshire. And then that will be sent towards the data analysis for all the data analytics partners who are part of the consortium to do the data analysis. So if there is a problem, then it will generate an alert. If there is no problem, then there will be no alert generation. So this is how we plan to do the REAMIT technology across the different pilots in Netherlands. So this brings us to the end of the first scenario that I explained, and now we can move to the second scenario that we have, that REAMIT project is trying to address. This is special. So sensors used in the earlier case are traditional sensors. As you can see, there were no new sensors used. There is only temperature sensor, there's only GPS sensor, there's only maybe humidity sensor could be used, and these are the few traditional sensors that were used. So now in the next REAMIT scenario, the Raman spectroscopy is used. So in this, basically the quality of food is predicted by the kind of spectrum that is obtained by the Raman spectrometer over which is measured over the sample of the food. So the Raman spectrometer has 1 second. Yeah, so this is how the sample Raman the spectrum looks like. So on the x-axis we have wave number, and on the y-axis we have Raman intensity. What it does is basically it has a probe which measures, which is kept on the food sample, and for every time instant it gives these graphs, which are basically the composition of the chemical composition or the Raman spectrum of this that corresponds to this particular food sample for a given time instant. So for each time instance you have a specific structure of the wave Raman spectrum. So the research aims to, the Raman spectroscopy aims to capture such spectrums for a continuous amount of time. Say for example, for 5 minutes, for 10 minutes, you get million number of such points out of this Raman spectrometer. So how this spectrum changes over the time is what the Raman spectrometer aims to, this research aims to observe and finally arrive at what particular structure of this spectrum the spoiled quality of food is detected. So by visual inspection, we can say that this particular color is spoiled. So for that spoiled food, they capture the Raman spectrum and consider that as a benchmark. And once we have this benchmark, then we can predict the quality of other samples of food and say that this particular quality is good or bad. And by applying a number of predictive mechanisms, we can say that this quality is good or this quality is bad. And so ultimately, for first instance, the Raman spectrometer aims to get that corresponding wave number, which says that this wave number for this type of food, the quality is good or bad. So and once we have further amount of food samples, we can say that if it reaches this wave number, then the food quality is bad or good. So this is laboratory testing, and so once they are able to arrive at a particular wave number for a given number of for a given type of food, then they would transport this into the trucks. As you can see in these pictures, they transport this into the truck. Say for example, the food, when it is transported in this truck, a sensor would be installed inside this truck and send all the data towards the lab, which can be then taken by the Raman spectrometer probe, and they would generate the graphs, and these graph data will be sent to the Bedfordshire server, which can be analyzed using different data analytics tools, prediction mechanisms, and predict the sample of the food. So for this particular pilot test, chicken samples from a particular local company were used. As you can see in the next in the slides which I mentioned here, these are some chicken samples which were used to generate the Raman spectroscopy. So this is still under research, and they're looking for a pilot scenario to do the testing. And so this brings us to the end of the second kind of scenario that we have for REAMIT project, and we are trying to address, and the REAMIT project basically tries to address. The third scenario is I would like to present the third scenario over here now. So just to summarize, the first one used traditional sensors to build the traditional sensor to measure the data. The second one used some new kind of technology known as Raman spectrometer to measure the quality of chicken samples. And so in this particular pilot test, we use the traditional sensors. The temperature and humidity sensors are being used. So what is the scenario? Let's have a look on the scenario. So this is a family-owned beef manufacturing company in Northern Ireland. So they have two problems basically in their processing plant. Um, so this particular pilot test aims at the processing stage. So the REAMIT project, the scenarios that we try to address in the REAMIT projects, there are different scenarios. Like first scenario addressed the transportation phase. So that is like a last mile delivery phase. Whereas the second Raman spectrometer, it is also a transport. It also aims to address the transportation, address the quality control in the transportation phase. So, whereas this one aims to address the quality control in the processing stage or right at the source, if we can say, which are early stages of the supply chain. So they have a processing plant, or you can say a slaughterhouse they have, and basically they have two problems. The first pilot test aims to detect the clostridium esters in the processing plant, so which is a big problem in for meat plants, meat production plants. So they really don't know when, at what stage this clostridium ester starts to appear. So once they appear, they would have to remove all the samples of meat and just simply throw it off, and they don't have a technique to predict the occurrence of clostridium esters in the early stages. So they can be detected once they're already formed, and they would have to chunk out all the samples, which are the whole batch of that particular meat. So REAMIT project aims to install some real-time processing or sampling mechanism, so that they can be instantly detected in the supply in the process, in the assembly line itself, um, by seeing either the color or the odor of the meat that is flowing through the assembly or the conveyor belts. So, or if they find out that this meat is more prone to spoilage, then they will subject it to further processing or subject it to spray. They have some spraying mechanism to remove this bacteria, so they may do some spray to these based on the inputs given by the REAMIT technology through the app. So this is first pilot test. That's first problem that we're trying to address. The second is the meat. They are kept in chambers known as dry aging chambers. So as you can see, the chamber, the figure that appears towards the right is a dry aging chamber. The meat is hung in different portions of this. So right now they do not have a proper procedure to measure the weight loss of food. That is, they remove the food from this chamber once they arrive at a particular amount of weight loss, and they don't have a specific scientific way of measuring the weight loss. So they want to install both temperature and humidity. So based on the humidity of the surrounding environment, they would say that this particular meat now has reduced this much amount of weight, and now they can be removed from this drying chamber. So to have this thorough scientific technology, they want to use REAMIT technology to detect the quality of meat and also the weight loss of the meat in the dry aging chamber. So these are the two major challenges that REAMIT technology aims to address with this company. So this is the next pilot test that is being used in the REAMIT project. So as we now discuss three pilot tests, and this we moving on to the fourth kind of pilot test here, which is known as the cyberbar pilot test. So the pilot, the scenario is not decided yet, but the technology, I would like to present just the technology here. So the cyberbar technology essentially is University College Dublin is an expert in this particular technology, and they plan to use this to measure or track the quality of food. There are pros and cons of using this approach. Um, so the advantage is to have direct information of the quality of food. As you can see, this etching is known as the cyberbar technology. So each food or each food item would be etched upon with this kind of barcode or a serial number, which will then be read by meters or by reading meters, and the quality of food will be tracked with the help of this cyberbar etching technology. In the earlier cases, if you see, we are measuring the food from a certain distance, measuring the quality of food or temperature or humidity, not directly on the food, but from a certain distance. So that may give some errors in the accuracy of the temperature, accuracy of the humidity that corresponds to that particular type of food. So in this case, that kind of ambiguity is eliminated, and you directly measure the quality of the food directly from the food itself. This several customers may not want to take or accept this kind of technology. So this is the challenge of using this technology, and therefore in REAMIT we are using planning to do this, but majorly we focus on traditional sensors and Raman and newer sensors such as Raman spectrometer, and there is another one known as 3D fluorescence as well. But due to COVID, the pilot test for 3D fluorescence is not yet not have been possible, but still the sensor search, the corresponding 3D fluorescence sensor is very new in the market and is not easily available. So there's a lot of search being conducted to obtain the right kind of 3D spectrometer to do the 3D fluorescence measurements. So these are the different pilot tests we have in the REAMIT project. And finally, I would like to present some progress in the development of the app, which essentially connects all the data that is collected in the REAMIT project. There are different types of primary data, there are different types of metadata that are used by the mobile app to suggest the status of the food item transported to all the different actors. So as you can see, the different types of data that the app uses is vehicle GPS tracking of the vehicles, GPS tracking of the drivers, and then the actual departure time of the journey, the actual arrival time of the journey. Also have the data of GPS data and to know the shortest route from one origin point to the destination point, and how much amount of petrol is saved by using which amount of route. And the app also helps to uh, organize the drivers. I mean, they can suggest different options to the drivers as to how best they can organize their journey. So if they can use the sat nav for a journey, whether they can use the sat nav, or sometimes using the sat nav is efficient, fuel efficient, shortest distance, sometimes it is not. So the app would say whether to go for this or not, sat nav navigation, and then whether they can depart and when they can arrive, what's the appropriate time they should depart based on the traffic conditions, and what is the appropriate time they will arrive if they start at this time, and know if a phone is being charged or not, know if a phone battery is low, know if these are all different types of minor advantages that app also aims to provide uh, when the driver is on the run. So these are just sample trial runs made while traveling. This is the actual screen of the app. So while traveling from their home to the conference meeting, we just did a trial run, and this is how it looks over the Google Map. And the app actually uses the Google Map to show the tracks, to show the travel path on the screen. So you can select different routes based on just like how you can select on the Google Map. So you can select, and if you select this particular route, it will show the temperature, the humidity, and the on any time it's recorded by the app. So these are the three different types of sensors that were used during the trial run. So WISE 4220, 4210, WISE 4470, 4471, WISE 4610, 4671 are different types of sensors that are available, commercially available in the market, and they were linked with the app to give the results for a particular route travel. So this is the kind of architecture that is there we have at the moment. So the app collects all the data from all the sensors, and finally it transports to the Levstone gateway app. So the app, it also has a gateway, so, and then finally to the cloud storage, which can be then be used for analysis, etc. So this brings us to the end of all the REAMIT scenario presentations, scenarios that are there, and how they are connected via app to the Bedfordshire server. And before concluding, I would like to present a small work that we have done in building an optimization model for reducing food waste. So the previous efforts that I explained so far is a real-time kind of data analysis that we are trying to do. So apart from real-time, there can be also offline kind of work, which an optimization model can help us simulate and analyze the information that we have so far. So because an optimization model cannot be essentially deployed in real time, because if the model is simple enough, it can be deployed, but if it's complex, then the real-time synchronization of optimization models becomes challenging. So it is important for us to see how much amount of data variables, how much amount of problem size is there, and to what extent an optimization model can actually be used in real time. So before we can do that, we can always try and solve an optimization model and see how I mean, how much cost is involved in reducing the food waste, and how much we can save the cost by reducing food waste, just to have a idea of how much food waste by saving, as to have an idea, and by choosing different options of technology, how much food we can save and how much food waste cost we can save. So in the literature, we have in the past, by going through the literature, we see that there is less amount of efforts for integrating transportation network design with the quality control mechanism. So this study aims to address this gap by integrating the quality control of maintaining the food within the respective temperature and the respective humidity levels with the transportation network design. So to fill this gap, the kind of scenario that this problem aims to address is a transportation scenario where we have three different types of transport modes. That is, vehicles which are equipped with which are not equipped with temperature and humidity control technology. Vehicles which are having, second one is vehicles which are having temperature monitoring but not temperature control facility, and third, vehicles which are having both temperature monitoring and temperature control technology. So in the previous literature, such kind of explicit focus on the different types of technology enabled vehicles were not seen. So in this particular research, we aim to address these two important things. One is to capture how different three types of technology enabled trucks can be used, or which is more cost efficient. And second, how temperature and humidity thresholds can be integrated into the transportation network design. So this is a basic scenario. So we considered a sample scenario of two farms having three productions, and which are transported using, as I mentioned, three different types of vans with no temperature control, vans with temperature control but with no monitoring, and vans with temperature control and monitoring. So, and finally, The sample scenario addresses to transport it to 3 different supermarkets. So the optimization model basically consists of the objective function to minimize transportation and food wastage cost, and different constraints that are related to this particular objective functions is vehicle related constraints such as vehicle capacity, or and then temperature and humidity threshold constraints, that each of the food item that is transported should lie within a particular lower and upper limit of temperature and lower and upper limit of humidity, and basic demand and farm capacity constraints, which are basic to any transportation optimization problem. So at the farm, the capacity of the farm should be sufficient enough to meet the demand. So the amount of food that is taken from the farm should be always lesser than the maximum capacity, and the amount of food that is sent to the supermarket should be either greater than or equal to the demand that is available at demand that is uh, at that particular supermarket of that particular food type. And finally, maximum number of trailers available for transport is also considered as a constraint. And so different inputs that we give to the model are distance between farms and consumer demand points, unit transportation cost, demand at different customer points, number of available crates for transporting the food at each for each food type, and lower and upper temperature threshold, lower and upper humidity thresholds. And finally, in the outputs, we aim to arrive at shipment and quantity routing decisions, minimize total shipment costs, food wastage cost, and food waste reduced finally. So this is the mathematical equation we have uh, for the optimization model. So the decision variables of the optimization model are mainly two. One is food quantity of food quantity of type K transported from farm I to supermarket J. So as I mentioned earlier, there are this is generalization of the scenario that we presented earlier. Earlier, we presented that there are 2 farms and 3 supermarkets. So this is a generalization of that particular scenario, where if there are n farms and n supermarkets, then the same model can be applied. And food quantity of type K, that is, now in this case we have considered 3 products, and there can be K number of products, and using transport van V. So we are considering now 3 types of transport vans, which are vans with temperature and without temperature and monitoring, temperature and vans with temperature monitoring but no control, vans with both temperature monitoring and control. So these are the different generalization and decision variables, general decision variables x, I, j, k, v. And the second type of decision variable is NIJKV, which is number of crates used to transport the food type K from I to supermarket J. So the objective function is modeled such as minimize Z is equal to triple sigma ijk c ijkv x ijkv. So the first part is the transportation cost of transporting the food quantity x ijkv, and c ijkv is the unit transportation cost of transporting the food from farm I to supermarket J of food type K in vehicle type V. So this is the total transportation cost for a given particular scenario. And the next 3 terms correspond to the penalty cost of not complying with temperature and humidity thresholds. So PT means penalty of not complying with temperature threshold. PH means penalty of not complying with humidity thresholds. And finally, we subtract PTH, because when we do PT and add the amounts PT and PTH, what happens is there might be a case where a particular crate does not comply with both temperature and humidity. In that case, it will be added towards T and added towards H. So we should subtract one amount, one particular penalty, because over here it is added 2 times. So we should subtract once. And that's the reason why adding minus PTH to this particular equation would give us the actual total cost of transportation plus food wastage. So this is the construction of the objective function. And these two are basic constraints which say that the total amount of food grains transported should at least satisfy the demand at the supermarket J. We have written greater than equal to because it simplifies the problem, and if we do equal to, then it will be a strict kind of constraint. So relaxing this a bit, putting greater than equal to demand would help us to arrive at the solution faster. And the capacity constraints at the farm, total amount of food that is lifted from the farm should be less than or equal to the total capacity available at the farm. Um, and for this, so there are other constraints as well before going to the methodology. Like I mentioned, constraints of vehicle trailers, number of trailers that are used, and there are some other constraints which are not presented here for the benefit of time. So the methodology that we used for this particular optimization model is particle sum optimization, because in some of the other constraints there is a nonlinearity in the constraint, so it becomes a nonlinear optimization, and therefore we use this particle sum optimization to solve. This is a small problem set which has only 18 total number of variables with 2 farms, 3 supermarkets, and 3 food types. So 2 into 3 into 3 gives you only 18 variables. So this is a small problem set, but for larger problem sets, this methodology will be useful. Therefore, we have used this. If we have some 1,000 variables, we increase the number of problem sizes, then still the same methodology can be used and used for arriving at a near optimal solution. So this is a since the focus of presentation is not on the particle sum optimization, I would like to skip this. But just to be brief, PSO technique is a meta-heuristic optimization technique which can be used significantly to arrive at near optimal solutions in real time, and it's better compared to other. I mean, of course, meta-heuristic algorithms are highly problem specific and needs to be tested for different types of problems. So future research can be done if this problem can be solved in a better way by any other better technique. So, but for now, we are trying to investigate the efficiency of the solution using PSO approach. And the scenario kind of we have adopted for this is, as I mentioned earlier, for 2 farms and 3 products. So there are 3 different types of crates that these 3 products go into. So we considered banana, orange, and apple as the 3 products, and the supermarket demand, the farm capacity, and we make a decision whether banana goes into ambient, chilled, or frozen by ourselves only, because each food type has its own kind of predetermined crate. And then finally, the temperature and humidity thresholds for each food type are taken from the literature. So for banana, the lower and upper thresholds are 13 degree and 15 degrees centigrade. For orange, 3.33 and 8.89. For apple, -1 and 4.44, and similarly humidity. So these are taken from standard literature, and we have obtained the convergence graph, that is the point at which the cost is not minimized any further, and we are yet to further extend this research in terms of specifically continuing this for larger problem sets. So this is the main contribution out of this particular optimization model, where as I mentioned earlier, it considers 3 different transport vans, and it integrates the total transportation cost with total cost of food wasted, which is not present in the previous literature. And so this is work was presented in Euroma conference, and it still needs a lot of improvement in terms of presenting the results. So we have just arrived at the convergence graphs, and still we are calculating the deeper insights from the results, and also extending this to larger data sets, and including carbon emissions and sustainability perspective. So this is work is still planned for extension. So if you're interested, you can approach me to work on this also. Um, and finally, the REAMIT project aims to gives a lot of benefits to end users. So firstly, as mentioned in one of our earlier slides, it aims to reduce the it aims to establish something known as food fingerprint. Just like carbon footprint, we aim to establish something known as the REAMIT project, something known as food fingerprint, which says how much amount of food is saved while you transfer when you redirect the food to the nearest consumer. So with the help of REAMIT technology, means with the help of REAMIT technology, how much food are we aiming to save? So that is known as a food fingerprint. And monitoring is yeah, because of the use of IoT technology, sensor technology, efficient monitoring of food is made possible, and especially for different environments, for food on the go and also for food which is at the warehouses, and connecting the different actors of the supply chain through the mobile app. So there is more connectivity in the traditional supply chain. People work in a non-integrated manner, whereas with the help of technology, everybody comes to a single platform and they get to know the status of the food, and they're all connected with each other. So, and of course, ultimately it saves a lot of time and saves a lot of money in terms of the amount of food waste reduced. And once the project is commercialized, then it can be applied across larger scale. So larger is the scale of the pilot test, larger is the savings. So if you apply smaller investment, smaller scenarios, then savings might not be huge, but if it's a large organization, then savings will also be very high. And it helps to improve the revenue. By using this technology, we can also claim higher prices to our food. There can be a stage, because people, customers also look at how well the food is maintained, at what level or what quality levels. And because of the technology, higher quality levels will attract higher customers, and it can be targeted for higher segment of customers and generate and help to improve the revenue as well. And also it reduces the carbon footprint because of reducing the food waste. Moving on to the next set of advantages, it also helps to develop a whole network of food manufacturing technology using industries, and the whole industry kind of exposes itself with the different kinds of people, with different kinds of networking people, different kinds of industries to do the digitalization of the whole supply chain. So you have access to lots of academic institutions. Industry will be connected with academia, academia will be connected with industry, and so this kind of initiatives will help to develop network and collaboration. And there is quality assurance also. Continuous, like I mentioned earlier, use of technology will help us to maintain the quality of food, and also promising to customers. And with this, we can also arrive at decision support tools, new decision support mechanisms to comply with the real-time food quality monitoring systems. A new decision support mechanism should evolve, and this evolvement will take place with the help of this initiative. And ultimately, as I mentioned, to comply with real time, there should be a tailoring of traditional decision support. So that's what we say. Tailored means we need to improvise. We don't have to necessarily bring in very new new altogether technology, but improve some of the old technologies, already existing ones, to suit to the context. uh, and um and there is a lot of scope in the sensor technologies. So we will realize which sensor technology is best suitable for our own application, because if you see the sensor market, it's an ocean. And once you complete this research, we will get a database of all the sensors that can be used for different kinds of scenarios, different kinds of foods applicable to reduce the food wastage. So And finally, data driven decision making. So because of the huge amount of data, now once at the end of the project, once all the data is collected, we have huge lots and lots of amount of data that can be used for doing some historical data analysis, and then finally make a decision for future pilot tests, and we can have a database of rules or decisions with us based on the experience we had from REAMIT project, and which can be used for future projects. So we can also do this kind of data driven decision making uh, in addition to real time data. So this brings me to the end of the presentation. Thank you very much for listening patiently, and sorry for the hiccups in between the presentation.
So thank you, sir. Thank you very
Due
much.
to network connections. So this is the REAMIT present. I always go to this. You can send an email if you want to collaborate with REAMIT project in any way. So this is it. Thank you.
Thank you, sir. Thank you very much. It's a wonderful presentation, wonderful session, sir. Hope how you used, internationalize your project, how IoT played important role for to control food waste and agri sector. It's really enlightened, exclusive. We have a more scope to do research in particular this area. And yes, of course, I would like to call upon participant. Good. Do you have any queries now?
Yes. Hello, sir.
Yes, sir. Please.
What are the sensors required for to collect this kind of information? For example,
Sorry,
hello.
can you be a bit louder? I
Yeah, yeah.
was not able
Okay.
to.
A
Okay.
bit louder, sir.
Can you give me some sensor information regarding their capacity to sense the quality, like moisture quality, temperatures, and
Yes, of course.
uh,
If you can send me an email, I can share you with some of the sensor details that we have collected for this project.
and
Uh,
one more thing. Whatever the sensing information we are stored by using cloud, okay, which are the cloud platform is available on the free of cost for store the data?
so we actually didn't investigate much on the cloud services because we hosted a physical server.
Okay, okay,
Because of data, because if you host a cloud server, ultimately data will be shared with third party. But although they promise that we have all the data security protocols, everything, but our line manager was more bent upon using a physical server rather than a cloud service. But having said that, to answer your question, free services means uh, uh, if you go for Google Cloud platforms, some amount is, I think, free when you register. But if you want to do it for longer time, you have to end up paying for their computational services. But for us, we investigated Amazon and Microsoft, which are not free, uh, which are not free at all, because if you purchase some, they will give free, but for initial you have to make some purchase. But it was not cost effective for us in the long run, because they give you like 2 year 3 year subscription only, and at the end of the day, after 3 years, you have to give away with that. So we wanted to purchase a physical server, and so that you can have it for lifetime. It costed there it costed about 8,000 to 10,000 just for the hardware, and another 6 to 7,000 pounds for the software, Microsoft software licensing. But you will save some amount of the cost if you use Java, if you use Java platforms, or sorry, if you use Linux platforms, you will save some amount of the cost, because if you don't use Microsoft, then you can save some cost when you use Linux, because Linux provides free software platform, but hardware you have to buy. And the pros and cons of that is, if you use Linux platforms, you have to build the security protocols by yourself to ensure data security. Whereas if you buy Microsoft services for like SQL, Microsoft services, Microsoft Windows Server, all these come with the default security protocols, and they have their own security mechanisms. So don't have to worry much about data security issues if you go for these Microsoft purchases. So these are the pros and cons of different approaches.
And one more thing, sir, which microcontroller is used for that, for processing? A Raspberry Pi or Arduino?
You're talking about the data collection side, right?
Yeah, yeah.
Actually, the data collection was conducted by another company. What they have used is the direct sensors. They have an inbuilt microcontroller. We just have to choose that particular type of sensor. Like one of the type of sensor they used was ELSIS, which measured temperature, shock, vibration, everything. So if you go through the description of the ELSIS sensor, then you will get to know all the information of the which type of microcontroller or microprocessor that particular type of sensor. So different sensors use different types of sensors. So they have their own gateway, and they transfer the data from the sensors to this gateway, and this gateways transfer data directly to the cloud. So we didn't have to choose the specific microcontroller or microprocessor to send the data.
Okay, okay. Thank you, sir. Thank you very
Yeah.
much.
So thank you, sir. Thank you very much. I would like call upon participant. Do you have any query?
Sir,
Yes, yes.
hello.
Yes, sir. Please, sir.
Sir, putting the sensor inside the vehicle, that can change the pH value of the fruits because they
Sorry,
will
putting the
emit some
sensor
radiation.
inside the vehicle.
Yes, because each sensor they will probably radiate some radiation, and that can change the food quality.
Yeah, I think your question is really a valid question. Um, so some sensors, even though they like there are different sensors available in the market. So based on the standard practices, we can choose the kind of sensors which is less affecting the surrounding environment. Some of them come with membranes, some of them come with some kind of protective environment which do not affect maybe the pH value. But we haven't yet come across that particular challenge so far. Uh, but ultimately, even though if it changes the pH value, we get to know the readings of the actual pH value from the sensor. So if it's falling below a particular quality, then we'll get to know the quality is reduced or increased. The final value given by the sensor is going to be the actual value that is there inside the food. So even though it reduces the pH value, the quality that is shown is actual pH value. So we don't have to worry about um, whether it is reducing. It's a matter of research. I mean, we can do research in terms of whether it is reducing the pH value of the actual food item by putting the sensor. I mean, by increasing the number of sensors, by reducing the number of sensors, as a matter of research. And it's a very valid point that you have raised. But for now, we are only concerned about the final quality of the food product measured by the sensor.
Because, sir, we are measuring the environmental condition inside the vehicle. And is there any sensors that will measure the quality of the fruits, meat, etc.?
Yeah. Sorry, can you say that again?
Is there any sensor that can measure the biological property of the fruits which are stored in terms of the quality actually? Because all
Um,
these sensors, they are measuring the environmental conditions of that particular storage.
yeah, yeah. To measure the biological quality of the fruit in real time, it's very difficult, challenging, because to do using either by visual inspection or by temperature, or monitoring the surrounding temperature. Such kind of analysis is more easy in the laboratory setups rather than in the moving environments. Like I said, one of the technology that is used is cyberbar technology, which etches which etches its marking on the fruit, which is the nearest possible way to measure any biological property, like you mentioned. But at the end of the day, to measure the biological property, the challenge is we have to enter the food item. So once the food is ordered, the customer would not want external elements to touch the food. So that's the challenge, to measure the biological property during order dispatching or during customer.
I am asking these questions looking to our country, because in our
Yeah.
country the transportations for the 1000 kilometer, 800 kilometers, etc. So is there any sensor that can measure the biological property? For this, we can take one kind of the sample from the particular storage, so that we can measure how because ultimately that is going to be linked with the price. Okay.
Yeah. In the one, there is one technique that in the REAMIT project that we used to use to measure the biological property. If you want to do sample-wise quality
Yes,
selection,
yes.
I mean, there is something known as PCR, polymerase chain reaction testing.
Okay.
So in that, generally it is used to detect the amount of bacteria, etc. Bacterial level. But I'm sure it can also be used to measure, I think, uh, uh, pH levels. I'm not really sure at this point, but it is one of the technique that we used to use to measure bacterial quality on the food sample. That is one of the, as I can say, biological property, not directly of the fruit, but something related to that.
Okay. One
But
more, sir.
I'm not really sure exactly is there any technique for pH level measurements, but somewhere around PCR techniques can be used to measure
Okay. Okay.
biological property.
Sir, you talked about that mobile app, Stone. Is it free, available, or paid app?
The mobile app, it was developed by Levstone, a company which was part of the REAMIT organization.
Okay.
So they purchased these three sensors known as which I presented earlier in the slides, and they
Yes, yes.
modified the firmware of these sensors to suit to REAMIT technology.
One more thing, sir. Would you like to share the specification of the sensors which you have
Of
used in
which
this
of
project?
which of which sensors?
For this project, you have used a lot of
Okay.
the sensors.
Yeah, of course, I can share with you. You can just drop an email. Can share with me. I will just. I'm just writing my email address in the chat box.
Okay.
Yeah.
I think some questions from chat box. Could you please go?
Okay.
Soumya, a question from Soumya. How are the sensors powered?
They are battery powered. Basically, sensors are all because they are put in the stationary, moving environment, so they are all battery powered.
So I think I would like to request any participant, can you give oral feedback regarding for this session? So, yes, yes. Sir, voice is not clear, Abhishek. So I would like request participant, can you give please a feedback of oral feedback of this session? Mr. Prashant Sharma, sir. Hello.
Hello, good afternoon.
Yes, sir.
Sir.
Yes, sir. Yes, sir. Please, sir.
Sir, thank you for organizing a great workshop on faculty development program on behalf of IIPM and from AACT. It is a great learning experience where you can learn how technology has been changing the way of industry. Every industry, not only agriculture, allied industry, even financial markets and other markets, how the AI technology and machine learning programming will be helpful to making the sophistication decision by using the accuracy scientific result of the analysis from the programming, whatever you are using, methodology or tool you are using. So it will be help us to take good decision. And this FDP, I can say it will learn at least what is the basic concepts and how industry has been changing from traditional mode to modern and sophisticated mode. Thank you, sir. For every session is very good learning experience. And once again, thank you for providing this opportunity to attend this wonderful FDP.
Thank you, sir. Thank you, sir. And I would like to thank to our resource person, Lohithaksha, sir. It's wonderful session, sir. Sure, IAPM and we'll very much happy to collaborate with your projects. Since we are in central government, we have different projects. Still, we are planning for further coming project with the collaboration with you, sir. Already Ganesh sir also we talked that, and further coming projects definitely we will have a collaborate with you, sir. Really wonderful session. How you explain about your project experience, how model methodology applications. Really, it's good, sir. The adoption of this model when you implement in Indian like a contest, that will be good, because today we are fully demanded and fully we are focusing about supply chain, how best we can implement supply chain in India. See, that is what everywhere people are now doing research work. Since we IAPM, we have an n number of projects talking about the food processing, supply chain, AI, machine learning, n number of projects every professor doing. But sure, we'll have a very big project very soon. We'll collaborate with you, sir. Thank you very much. Really, it's a very informative session. Hope all the participants also maybe enjoyed, may learn how you explain, how you just present your things. Yes, initially some technical issue, that's a matter maybe everywhere is like happening in this. Thank you very much, sir. I'm sure further collaborated, inviting you for different FDPs. Thank you very much.
Thank you very much, all Professor Ganesh and Professor yourself. Thank you very much for this opportunity, and I also look forward for collaborating with you, given our similar area of interest and
sure.
And all your experience in this agri-business supply chain management.
Sure, sir, definitely, sir. Thank you, sir. Thank you very much.
Thank you so much.
Logi, sir. Thank you for your time. We'll keep in touch with you, sir.
We'll keep.
Sure, sir. Yes, sir.
Sir, you want to talk to participant regarding afternoon session?
Yes.
Yeah.
See there some more times.
Thank you, sir. Thank you, sir. Yes.
Thank you, sir. See you. Yeah.
Yes. Dear participants, afternoon session already I explained you. First half an hour, that is 2 to 3 o'clock, 2 to 2:30. Will engage by the Ganesh sir. Going to be talk about different sorts of open available data. Going to be explain you and demonstrate you. And after that, 2:30 to 3:30 will be an exam that will be contain MCQ questions 40 marks and 9 open-ended questions that is exclusive for description about the how individual session outcome you learn from that individual sessions, followed by the validity like 15 or half an hour, 15 minutes. This is the afternoon schedule. Accordingly, we will plan. Actually, we schedule Mr. Aravind from Crop in Bengaluru due to some technical other reasons. He's not able to attend. He's not able to join. So many participants also requested to take Ganesh sir for another session. That is the reason we decided to requested to Ganesh sir will going to be handling another session for half an hour. This is afternoon session. I would like to call all the participants. Please be on time. We will start sharp at 2 o'clock. So Ganesh sir,
any clarification from a participant? So sharing the link, that Google Form link in the chat window 2:30. That is the examination. During that time, you have to on your camera also.
Yes, sir. Because that is recording. Your exam will be recorded and will submit to the AICT. So we will not send that exam link to your email ID. We will share in our chat box, and everybody while writing exam, you should on your video mode, because it is recording. They're going to be analyzing and they're going to assess you for AICT. I would like request everybody while writing your exam, switch on your video. That's all, sir.
Yeah, any clarification from participant?
I request you any clarification for the participant. So don't worry, we will share you whatever data, whatever presentations shared by the resource persons, we will share to you.
There is some problem with that.
Now it is working, sir. I think by afternoon we'll share it.
We'll share with you, sir.
Pramod sir video, now it is working, sir. We will share you by afternoon. Shall I wind up, sir? We'll.
Yeah, if there is no clarification, we'll stop here. We'll again meet at 9.
Yes. Afternoon. Yes, 2 o'clock. Thank you very much, and we will start at sharp 2 o'clock. Sure, we will share all data through WhatsApp.